Welcome to this video talking about activity of radioactive sources. There are three main outcomes here. You need to know what activity is. That's the first statement there. You need to be able to calculate the activity using the relationship. And you should be able to describe how you would carry out an experiment to measure the activity of a radioactive source. Radiation is caused by unstable nuclei of atoms splitting. This is called radioactive decay. Activity is the number of these decays that take place in a second. So the number of decays per second or the number of radioactive disintegrations in a second. Both these sentences mean the same thing. Disintegration, also called a decay, is what happens when a radioactive source, that's just a radioactive material, emits, gives out ionizing radiation of any form, whether alpha, beta or gamma. So decay is an emission of an alpha particle, a beta particle or a gamma ray, or a combination of all of those. And it's called a decay or a disintegration. The unit to measure activity is the becquerel. And 1 becquerel is the same as 1 decay in a second. So 1 alpha per second is 1 becquerel, 1 gamma per second. But we can see from the experiments we've looked at earlier that the counts can be a lot higher than this. So activity has the symbol A, the number of decays N, and T, the little t is for time. So N being the number of alpha or number of beta or number of gamma, the number of disintegrations or the number of decays, the number being detected by the Geiger-Müller tube and counter. T is the time measured in seconds, and A is the activity measured in becquerels, BQ for short, capital B, small q. 1 becquerel is a small dose, so we often have kilobecquerels and megabecquerels. So the K meaning 1,000 kilo and the M meaning 1,000,000 mega. Here's our background count. Notice that our count here is random. We can't predict when it's going to take place. So using the Geiger-Müller tube there and the counter, we can detect the background radiation. This is the radiation that is there when there's no source, there's no radioactive material there. And we need to do that first, and then once we know how much the background radiation is, we can then work out how much is coming from our radioactive source. So we measure the background radiation for a minute, record that number, then we measure how many comes from our source for a minute, and then we take that away from to get our corrected count. So if there was 25 counts in a minute, background radiation, 25 becquerels, and we measured 100 becquerels from our source in a minute, what's actually coming from it is 75, because there'd be 25 there without it. And then we could work out our activity, dividing that 75 by 1 minute of seconds, which would be 60. So let's look at an example. A radioactive material decays 4,500 times in 60 seconds. Calculate the activity. So the activity is N divided by T, which is 4,500 divided by 60, which is equal to 75 becquerels. Remember, in physics, you should always show you're working the formula, substitute the numbers, and have the answer with the unit. Second question, we've got a radioactive source, this time emitting 2,200,000 in 1 minute. So we start with the formula, substituting the numbers, noting that for a minute we should be putting 60 seconds. Then we get an answer on our calculator there, which we then need to round because we only have two numbers for two significant figures for the number of alpha particles. So we round to 37,000 becquerels. Third example, calculate the number of decays that occur in 5 minutes if a sample of polonium-210, that's just a material, has an activity of 20 megabecquerels. So we've listed what we know down the side. We've got A, our 20 million becquerels. We need to work out N, and we have a time 5 minutes, which we realize is 300 seconds. We can substitute into our formula, and then we can rearrange our formula to get our answer. And we can either use it with scientific notation, as shown on the right, or we can just put the numbers. It doesn't matter, both are acceptable. So there are three things to know. The activity is the number of disintegrations per second, or the number of decays per second. Both are fine, and to be able to use the relationship. So there'll be some problems that you'll need to do to practice that. And then a description of measuring the activity of the source, finding the number of decays in a certain amount of time, and finding the background radiation count and taking that away to give the number of decays from the source from there.